Example 2, we're told that Jackson has $30 and that a bakery has cakes for $8 each and cookies for $1 each. We're letting x equal the number of cakes and y equal the number of cookies. And the function y equals 30 minus 8x, that's how many cookies y Jackson can purchase when buying a certain number of cakes x. So we'll go ahead and we'll make our function table. Now it doesn't make any sense to have negative numbers of cakes or cookies. So what we'll do is we're going to go ahead and start with, if we have 0 cakes purchased, how many cookies can Jackson buy? So f of 0 equals 30 minus 8 times 0, which gives us 30 cookies. We'll go ahead and we'll graph in the y direction the number of cookies. We'll make each tick mark represent 5. And if he purchases 0 cakes, he can purchase 30 cookies. All right, now we'll go ahead and with the next one, what if he buys 1 cake? F of 1 equals 30 minus 8 times 1, which equals 30 minus 8, which is going to be 22. So if he purchases, we'll make 1, 2, 3, 4. We'll make each one of these represent 1 cake that he purchases. So if he purchases 1 cake, he can purchase 22 cookies, which is going to be right about here. When he purchases 2 cakes, f of 2 equals 30 minus 8 times 2, which equals 30 minus 16, which gives us f of x equals 14. So if he purchases 2 cakes, he can purchase 14 cookies, which is going to be right about here. And then 3, f of 3 equals 30 minus 8 times 3, which equals 30 minus 24, which equals 6. So if he purchases 3 cakes, Jackson can purchase 6 cookies. And then we'll go ahead and do one more for good measure. F of 4 equals 30 minus 8 times 4, which equals 30 minus 32, which equals negative 2, which is going to give us the point 4, negative 2, which doesn't really make sense here. It would be somewhere down here, but he can't purchase a negative number of cookies. So we'll go ahead and we will connect our dots here to draw this line. And essentially what this means is we have, 0, 30, 1, 22, 2, 14, and 3, 6. And what each one of these points represents is x is number of cakes purchased and y is the number of cookies purchased. So he's spending all $30 and we're using cakes purchased as the independent variable. What's ever left over is what Jackson can use to purchase the cookies. So if he purchases 0 cakes, he can buy 30 cookies. 1 cake, he can buy 22 cookies. 2 cakes, he can buy 14 cookies. 3 cakes, he can buy 6 cookies. And then he can't purchase 4 cakes because that's more than the $30 he has. 4 times 8, as we showed down in our table, is 32. So at most he can purchase 3 cakes, which will give him enough money for 6 cookies.